Hello science fans and welcome to SHE-ensya. What is AI or artificial intelligence? What started the interest to develop machines that can think like humans? When did the creation of artificial intelligence begin? And why are we still pursuing the development of artificial intelligence? Why do we ask questions? The SHE-ensya Why series will dissect some of our most head-scratching who, what, where, when, and why questions, teasing out the scientific principles from historical records, conspiracy theories, and mass media. Join us in today's episode where we ask the question, why AI? Early on in the 20th century, science fiction made popular the idea of artificially intelligent robots. Some may remember the heartless Tin Man from The Wizard of Oz, while others are still haunted by the humanoid robot that impersonated Maria in the movie Metropolis. By the 1950s, we had a generation of scientists, mathematicians, philosophers, and dreamers alike who were fascinated, intrigued, or scared of artificial intelligence or AI. But what is artificial intelligence? Artificial intelligence or AI is a wide branch of computer studies concerned with building machines capable of performing tasks that typically require human intelligence. At its heart is the goal to replicate human intelligence in machines. But no singular definition of the field is universally accepted, because in defining AI as simply building machines that are intelligent, it doesn't actually explain what artificial intelligence is. Because how can we really answer the question, what makes a machine intelligent? The groundbreaking textbook Artificial Intelligence, A Modern Approach by authors Russell and Norvig approached the question by unifying their work around the theme of intelligent agents in machines. They explored four different approaches that have historically defined artificial intelligence: thinking humanly and thinking rationally, acting humanly and acting rationally. Norvig and Russell focus particularly on rational machines that act to achieve the best outcome. They noted that all the skills needed for the Turing Test also allow an agent or a machine to act rationally. But wait, what is the Turing Test? The Turing Test is a method of inquiry in artificial intelligence for determining whether or not a computer is capable of thinking like a human being. The test is named after Alan Turing, an English computer scientist, cryptanalyst, mathematician, and theoretical biologist who posited that a computer can have artificial intelligence if it can mimic how a human thinks or reacts given a particular condition. The original Turing test requires 3 terminals, each of which is physically separated from the other 2. One terminal is operated by a computer and the other 2 are operated by humans. During the test, one of the humans functions as the questioner, while the second human and the computer function as respondents. The questioner asks questions to the human and computer respondents based on a predefined subject, format, and context. After a preset length of time or number of questions, the questioner is then asked to decide which respondent was human and which was a computer. The test is repeated many times, and if the questioner determines which is the computer in 50% or less of the test runs, then the machine or the computer is granted the title of having artificial intelligence because its responses are considered just as human as the actual human respondent. Now, the turning point in the history of AI was because of Alan Turing, who explored the mathematical possibility of artificial intelligence. Turing suggested that we as humans use available information in our environment and logic in order to solve problems as well as arrive at decisions. So, why can't machines do the same thing? This was the central premise of his 1950s paper, Computing Machinery and Intelligence, where he described how to make machines as intelligent as humans and how to test this intelligence. Unfortunately, talk is cheap. So what stopped Turing from getting to work right then and there? Well, because computers had to fundamentally change. Back in 1949, computers can only execute commands and not store them. So this would prevent them to do any kind of intelligent decision-making. Another was that computing was extremely expensive. In the early 1950s, the cost of leasing a computer ran up to $200,000 a month. Only prestigious universities and big technology companies had the resources to play around with artificial intelligence. And so, a proof of concept and support from highly prestigious individuals were needed to persuade funding sources that machine intelligence was worth it. 5 years later, the proof of concept was initialized through Newell, Shaw, and Simon's logic theorist. Logic Theorist was a program designed to mimic the problem-solving skills of a human, and it was funded by the Research and Development Corporation. It is considered by many to be the first artificial intelligence program and was presented at the Dartmouth Summer Research Project on Artificial Intelligence, hosted by McCarthy and Minsky in 1956. In this historic conference, McCarthy imagined a big collaborative effort that was brought about by the gathering of the best minds in the field for an open-ended discussion on artificial intelligence, a term which was actually coined during the conference. But sadly, the conference fell short of McCarthy's expectations. People came and went as they pleased, and there was failure to agree on standard methods for the field. Despite this, all the participants wholeheartedly agreed that artificial intelligence was achievable. And despite its failures, this conference actually set the future for the next 20 years of AI research. So from 1957 to 1974, AI flourished. Computers could store more information and became faster, cheaper, and more accessible. Machine learning algorithms also improved. Early demonstrations such as Newell and Simon's General Problem Solver and Weizenbaum's ELIZA showed great promise towards achieving the goals of problem solving and understanding languages, respectively. These successes, as well as the advocacy of leading researchers, convinced government agencies such as the Defense Advanced Research Projects Agency, or DARPA, to fund artificial intelligence research. But solving the initial challenges of artificial intelligence revealed a mountain of obstacles. The biggest was the lack of computational power. Computers, at that time, simply couldn't store enough information or process them fast enough. But in the 1980s, artificial intelligence was reignited by two sources: an expansion of the algorithmic toolkit and a boost of funds. Hopfield and Rumelhart popularized the deep learning technique that allowed machines to learn through experience, while Feigenbaum introduced expert systems that mimicked the capacity of human experts to arrive at decision-making. The Japanese government heavily funded expert systems and other AI-related endeavors as part of their fifth-generation computer project. From 1982 to 1990, the Japanese government invested $400 million in the goals of revolutionizing computer processing. Sadly, most of their goals were not met, and so funding ceased and AI fell out of the limelight. Ironically, in the absence of government funding and public hype, artificial intelligence thrived. During the 1990s and 2000s, many of the landmark goals of artificial intelligence had been achieved. For example, in 1997, world chess champion and grandmaster Kasparov was defeated by Deep Blue, a computer program designed to play chess. In the same year, speech recognition software developed by Dragon Systems was implemented on Windows. At this point, it seemed that there wasn't a problem that machines couldn't handle. Even human emotions was fair game, as a program called Kismet can actually recognize human emotions and mimic it. Now, at this point, we haven't gotten any smarter about how we are coding artificial intelligence. So what changed? Well, as it turns out, what was holding us back for the past 30 years was computer storage. And so if we follow Moore's law that suggests computer speed and memory doubles every year, then it has finally caught up to our needs, and perhaps has even surpassed it. We now live in the age of big data, an age in which we have the capacity to collect large amounts of information that is too cumbersome for a person to process in his or her own brain. The application of artificial intelligence in this field has actually been quite fruitful and has been applied in a huge variety of fields such as banking, marketing, even entertainment, and definitely in the field of science and technology. So we've seen that even if algorithms don't improve much, big data and massive computing simply allow artificial intelligence to learn through brute force. And so we have reached the point in history where a lot of the things we do are dependent on artificial intelligence. Be it something that appears so simple, like the ads that we see in our favorite shopping application, to the programs used by government agencies to predict the vastness and the speed of the spread of the COVID-19 pandemic, and even in the prediction of our future with climate change and pollution in the mix. And so science has spoken. Artificial intelligence is the branch of computer studies that seeks to create machines that are capable of doing tasks that require human intelligence. At its core is the ability to replicate human intelligence in machines. In order to check if a machine has artificial intelligence, it can take the Turing Test, where its responses are compared to a human expert. The speed of development of artificial intelligence is generally limited by the Moore's law, which suggests that the memory and speed of computers double each year. The history of artificial intelligence has its ups and downs, and we have reached a point where it is now everywhere, from our computers, our phones, our TVs, and so much more. So, why do we still need to continue the development of artificial intelligence? Well, because there is so much more in our way of life that we need to improve. Artificial intelligence provides 24/7 rational computing that, in the guidance of human minds and ethics, can make life better and more efficient. So what's in store for the future? Well, AI language seems to be becoming a big thing. Every time you call a company, you're often answered by a machine. In fact, some of us are even receiving calls from machines themselves. One can also imagine interacting with an expert program in a fluid conversation, or having a conversation in 2 different languages being translated in real time. Perhaps we can also expect driverless cars in a decade or so. But in the long term, the goal is general intelligence, a machine that surpasses human cognitive abilities in all tasks. And this is the most similar to the robots that we can see in mass media. But the next big question is, even if the capability is there, should we allow it to happen? Because when that time comes, or perhaps even better before it, we as a society will need to have a serious conversation about machine policy and ethics. But for now, we can actually see that artificial intelligence is steadily improving and also improving our lives, while also running amok in society. And that's it for our episode on artificial intelligence for today. I hope you were able to learn something from this short video, and if you did, I hope you can give it a thumbs up and also subscribe to our channel. If you have any comments, questions, or suggestions, please don't hesitate to message me, your resident Filipino scientist, in the comments section below. Thank you very much, and see you around!